So we're talking about air control systems. Well, building air systems, you gotta have some controls, like with any system. Well, not so much with drain back. You still need some control, but so finding a place to put ductwork, ductwork is harder than finding a place to put a pipe.
Yeah.
Which is harder than finding a place to put a wire. So there, it's a significant challenge. In this house, the duct, there's an 8-inch duct buried in the corner of this room. That's where we ran the duct down into the crawl space, and the return duct is back in the closet with the water heater.
And so, what would you like to share about it, the importance of air control systems, automatic air controls?
Well, dampers, tight sealing dampers, which is to say like valves, are crummy dampers are easy to find. They exist in the heating trade as zone dampers for furnaces, but they don't seal very well. They don't have to be good for that application. And for many years, I made tight sealing, motorized, and backdraft dampers, which, I'm not a reasonable source at this point. I've made some dampers.
Could you explain
recently.
how they can be made, or someone who might be interested in making them?
Anybody that wants to learn how to make them, I'd be happy to share my plans and ideas. Of course, the parts are a lot more expensive. The $15 motors that I used to get are now $175.
Wow. For motorized dampers.
Yeah, little gear motors.
Well, could you describe your backdraft damper that requires no motor?
Well, backdraft dampers, basically, I made like a little ring of metal angle. It was notched so that it could be bent around, and then I soldered in a piece of hardware cloth, and then I adhered and clamped to it some very special material that I got from 3M that is made of fiberglass, a thin fiberglass cloth with silicone rubber adhered to both sides of it. It's a very high temperature material, and I always arranged it so that it had kind of a slightly curved surface on the clamp, so that when it bent, it didn't bend right at one place. But I make that fall against the hardware cloth, and then I wedge that thing into a piece of duct and silicone up the sides of it.
And so what happens? Describe the dynamic with the air.
Air goes one way, the flapper would lift off the hardware cloth.
It's really light, right?
Yeah, really light, and then air can't go the other way because the hardware cloth falls back on it. And I found that I wanted to stiffen it so that it didn't flutter. So I'd silicone on a little wire to the top of it to make it like a little rectangular wire, bent wire, so that when it opened, it would kind of go up against the duct. And yeah, it's the kind of thing you play with. And I played with it, I designed it, and found some good materials.
And this would be to prevent cooling the house down, for example, with your collector that's out in the freezing air, right?
Yeah. If you've got an air collector on your roof at night, it's very cold inside, and the cold air in it wants to settle down through the ductwork, and a backdraft damper prevents that.
Yep. Interesting.
And the motorized dampers, their function, because this system, for example, has two modes of operation. It either heats hot water in which it's a closed loop through the water tank heat exchanger, or it heats the crawl space where it's an open loop into the crawl space and back. But for that, you need two motorized dampers. And at night, they're both closed. When you're heating water, one of them's open. When you're ready to quit heating water and do space heating, you close that one and open this one so that the air goes only through one of those paths.
How could someone who's industrious enough build a motorized damper that's actually tight, that closes tight?
Sure. I mean, I have my techniques for doing it. I'm not private about those techniques, but I'm not sure explaining them to this camera would be all that useful. But you know, here's some hints. I mean, basically, you have a duct with a round piece of metal in it, and you want a quarter turn. Okay, so the way I used to do that is I bent a little piece of 1/8 music wire to make it go on to attach it to the metal, and then had it come out and turn a corner and loop, and then I had a little ball bearing, and what I did was essentially I made the motor turn a quarter turn like this, so when it stopped it couldn't move, and then when it was open it couldn't move either. So I had a gear motor with an arm on it and a little bearing that rode inside a loop of wire.
And so the motor keeps a constant tension on
Well,
it.
the motor, when it stops, the bearing, the damper part can't move because the bearing is inside the loop, and it pushes. It pushes, and when it's open, it's the same story. So, because what I'm looking for is a 90-degree motion. I can do that so that it's sort of self-locking at both the open and closed. And then the motor has like a little cam on it, basically, that hits micro switches at both ends. The cam, in my case, was a screw screwed into the hub of the arm, so that when it goes one way and the other, it hits a micro switch and turns off the motor. So I use these little motors at 2Z813, I think, at Granger.
Granger.
Yeah, which they still sell. But you know, I've used, for bigger things, I've used bigger motors. But but motorized dampers. And you know, there are nowadays electronics is so sophisticated. You can have motorized dampers that have circuitry that senses their current draw, so that if they encounter an obstacle, they shut off. You know, the current draw goes up and then it shuts them off. That kind of thing. And if you're motorizing, say, a greenhouse window where it's going to be, you know, blowing dirt and maybe a dead bird or something gets in there, and you don't want to ruin your motor by having it run. Some of the sophisticated stuff is pretty useful.
You know, you're bringing up the greenhouse reminds me, there was something you were sharing yesterday about how important it is to have a greenhouse.
I think that's kind of a different little video.
But
just go for it here.
It's air, right?
You're going to edit, right?
You know, I could right now. I'll just cut it off and then we'll come back and cover that.
Yeah, I think we should go out in the greenhouse.
Okay.